In conclusion, you should be able to numerically modeling of the 1D parabolic equation by using the explicit method, implicit method, as well as alternative implicit method. You must know that the alternative implicit method is also known as Crank-Nicholson method. You must know the advantage and disadvantage for each method, such as the accuracy, convergence, stability, as well as the programming difficulty for each method. This is the comparison between the explicit, implicit, and also the Crank-Nicholson method in solving a parabolic PDE. We use various delta T in order to determine the temperature at time equal to 10 seconds at point x equal to 2 cm. So the actual temperature at point 2 at time 10 is equal to 64.8018 degrees Celsius. In this analysis, we fix the delta x to be 2 cm so that you can obtain the lambda to be equal to k delta t divided by delta x squared. Since k and delta x are constant, so when you reduce the delta t, the lambda will be reduced as well. Therefore, you can see when the delta t here reduced, your lambda will be reduced. In this example, the explicit method gives the poorest result in terms of the divergence and instability criteria. So you can see when your lambda is more than 0.5, the answer is far away from the actual temperature. So only when you choose the lambda less than 0.5, the answer will be converged to the actual temperature. So it's very important for you to choose a correct lambda by using the explicit method. On the other hand, for the implicit and Crank-Nicholson method, the result here is converged and stable for all lambda, including lambda greater than 0.5. So for the Crank-Nicholson method here, the result is converged and stable also for all lambda. So when we choose implicit and Crank-Nicholson method, one of the advantages is we don't need to worry about the divergence and instability. By using these two methods, it will be always converged and stable. So bear in your mind when you can choose the lambda to be less than or equal to 0.5, then we can use the explicit method to obtain stable and converged solution. For the cases that you want to save the computational time and make the delta t to be large, so in this case, when you have the lambda greater than 0.5, we can still use the implicit method or the Crank-Nicholson method to solve the problem in order to obtain stable and converged solution. In terms of the accuracy, Crank-Nicholson method gives the highest accuracy, followed by implicit method, which gives the moderate accuracy, and explicit method gives the lowest accuracy. As you can see from the table, the Crank-Nicholson method provides the best result, which is closest to the actual result here, followed by the implicit method and then explicit method here. In order to increase further the accuracy, we can reduce the delta t further or reduce the delta x further. The drawback of doing this is the computational time will be increased. One of the advantages for the explicit method is the programming level is easy compared to the implicit and also the Crank-Nicholson method. This is because the explicit method can explicitly calculate the answer in one formula. However, the implicit method needs the matrix and inverse method to compute the answer.